All right, so today we're going to learn about lines and angles. So we're starting chapter 3. This is 3.1. We have a couple definitions that we're going to talk about first. The first definition is a parallel line, or parallel lines. Okay, what are parallel lines? Take a trip back to Algebra 1. Okay, parallel lines have the same slope, so they're never going to intersect. So now we're going to put that into geometry and we're going to add a little to it. They're going to be in the same plane and never intersect. Whoops. Okay, we also have parallel planes. Parallel planes are going to be two planes that never intersect. Now, the reason that I added same plane for parallel lines is because now we have skew lines. What in the world are skew lines? Skew lines are lines that aren't going to intersect, but they are not coplanar. Okay, so they're not parallel, they're not moving the same direction. Since they're in two different planes, they're never going to intersect, but they're not parallel. Okay, and I know that's a little funky to try to think about. So let's draw some pictures. If I have this plane right here, whoops. Okay, here's our plane. We have this line, we're going to call this line AB. And we're going to have a line down here going the exact same direction. So right now, these two lines, we'll call this one CD. These two lines are parallel. Why? They lie in the same plane and they will never intersect. How we can put symbols on that is these little arrows on the lines, or sometimes you'll see them as little triangles like this. Okay, so those two lines are parallel. We also have parallel planes, which I normally in the class like picture two floating papers above and below each other. So I'll kind of try to draw that. Here's some parallel planes. So here's one plane floating, and then we're going to have another plane coming out from under it. So here's our, oh boy, that was ugly. So here's our two parallel planes. So here, we'll call this one U and this one W, okay? Now, for skew lines, I think it makes most sense when we draw a box. So if we draw a box over here, I know my drawings are fabulous, aren't they? So here's our box. Skew lines are going to be going different directions, okay? They're not parallel, but they're in different planes, so they won't intersect. So if we look at this guy right here that I'm making purple, okay, and then we look at this guy over here that's also purple, they're not moving the same way, okay? These two lines would be parallel. These two lines are not parallel. However, this one's part of like the top of the box. It's in a different plane. This one's on the side of the box, so it's in a different plane, but they're never going to intersect because they can't curve. Those are skew lines. So I want you guys to try a couple. Let's draw this box here, and we'll name all of the corners. Oh my goodness. All right, so here's our box. We're going to name this L, M, N, O, R, Q, P, S. Okay, so we're going to name a skew line. We're going to name a parallel line. Two lines like that, like railroad tracks, always represent parallel. And then we're going to do a parallel planes example. So, skew lines. Let's do skew to PS. So, who is skew to PS? There's a lot of options. Okay, I'm going to make PS yellow. So PS is right here. All right, so PS, I need someone who's not in the same plane, so it can't be part of the bottom of the box, and it's moving a different direction. All right, so let's do, how about ON? Those are moving two different ways. This is in the bottom of the box, this is on the top of the box, they'll never hit. So PS and ON would be a good example of skew lines. Parallel lines, let's go parallel to LM. So LM is green. Okay, there's LM. Now who's parallel to him? You have multiple options. We could do ON, so this guy. We could do QP, okay, because we could look at the back of the box. Or you can actually picture a diagonal that goes inside the box and connects it to RS. So you actually have three options for that one. I'm going to use QP. All right, parallel lines. Let's do parallel to plane MNS. Okay, so MNS. MNS would be this side plane right here. Okay, so I need parallel to that. So which plane is not going to intersect that? It's the one directly across from it. So this guy over here. How would we name that plane? We would name that plane with three of the letters inside the plane. So LQR. Okay, now I want you to try this one. I'm going to give you two lines and I want you to tell me if they're parallel or skew. All right, so let's do NS and LQ. Okay, go ahead and pause. Try that one. All right, we have a couple postulates to talk about. The first postulate is called the parallel postulate. Okay, the parallel postulate says if there is a point not on the line, then there is exactly one parallel line that goes through that point. Now, what does that mean? Okay, the words can be kind of confusing. Let's look at a picture. So we have a line. Here's our line, we'll call it P. And then we have a point that's not on the line. We'll call it L. So what this is saying is if we have a line and we have a point that's not on the line, there exists only one parallel line through that point that would be parallel to P, okay? Because think about it, if I drew this purple line any differently, I would intersect line P, okay? Now, similar to that, we also have a perpendicular postulate. Now, what is that? Now, just real fast before I give you that, parallel can be written with symbols as like two L's or two railroad track lines. Perpendicular can be that upside down T. So there's some good shorthands for you. So the perpendicular postulate, what does that say? That says if there is a point not on the line, then there is exactly one perpendicular line through that point. So very similar, except now we're doing perpendicular. So if I have that line, we'll still call it P, and that point that's not on the line, we can still call it L, okay? What does that mean? That means if I draw a line that is perpendicular to P through L, there is only one line that I could draw that will be perpendicular to make that right angle, okay? So there's your perpendicular postulate. Now we're going to go into some definitions. These next definitions you're going to see a lot. So get used to them, okay? We are going to draw two lines. They don't have to be parallel yet. So we have these lovely two lines, okay? And then we're going to draw a transversal. Now, what in the world is a transversal? Okay, let's name our lines first. M, N, and L. Okay, so what's a transversal? A transversal is a line that intersects two or more coplanar lines. Okay, so the transversal for this would be line L. Okay, it's intersecting line M and N. So from that transversal, it makes a bunch of angles. Let's name these angles 1, 2, 3, 4. Then we have 5, 6, 7, 8. So a bunch of these angles are going to have relationships. We're going to learn those relationships now. So the first one I want to give you is corresponding. What are corresponding angles? Corresponding angles, I like to think of as every other. Okay, every other. So what does that mean? I'm going to put a purple, let's do a purple dot. Okay, every other would be like 2 and 6. Okay, or if you want to think of like Foursquare, you have your Foursquare up at the top, 1, 2, 3, 4, and your Foursquare down at the bottom, 1, 2, 3, 4. So both of those angles are in the top right of each of their four corners. Okay, so corresponding angles are every other. Another example would be like 3, 7. You could do 1, 5, or 4, 8. Okay, any of those would be corresponding angles. So let's list a couple just so we have the examples. Angle 2 and angle 6. There's your example. Okay. Okay, so let's get rid of our purple dots. Let's do another one. Our next angle we're going to learn is alternate interior. Alternate interior. This is exactly what it sounds like. Okay, they're alternate from each other and they're between the lines. So picture these two parallel lines here, and anything between, okay, these are the interior, which means anything outside of that would be the exterior, above and below. So we're looking interior, and we need to look diagonal. Okay, alternate, so 4 and 5, or 3 and 6. So between the lines and diagonal is kind of the way that I like to remember it. Okay, a good example of those would be angles 3 and angle 6. Okay, now I'm going to use the same picture, but I want you guys, I'm going to draw a little picture off to the side, and I want you to try to find one of these angles. So from these two lines right here, 3, 4, 5, 6, 7, 8, name a corresponding angle to angle 7. Okay, name a corresponding angle to angle 7. Go ahead and pause the video and try that now. All right, so let's do another definition. The next one we have is alternate exterior. So alternate exterior, same as interior, except now we're above and below the line. So alternate exterior would be outside of the lines and diagonal. Okay, so what would that look like? Outside of the line, let me get rid of these little purple, or the green and purple dots. Well, it doesn't want me to get rid of it. There we go. Okay, so what do we have? We have outside of the lines and diagonal, 1 and 8, 7 and 2. Okay, So angle 1 and angle 8 would be a good example. All right, your last definition is consecutive interior. Sometimes you're going to see that as interior same side. So consecutive interior. Okay, between the lines and same side of transversal. Okay, what does that look like? That would look like between the lines, okay, so interior, same side of transversal, so 3 and 5, okay, or 4 and 6. So we're just going to get used to the definitions today. We are going to add on to this and actually get to solve later on in the chapter. So I want you guys to try one more on your own. Let's draw this actually we'll go from the same picture that I already have drawn right here. So this next one that you're going to try, I want you to name a alternate exterior angle to angle 8 from this picture right here, this purple one. Okay, go ahead and pause and try that. Once you finish that problem, you are finished with 3.1 notes.